composition of functions. When we talk about compositions of functions, we're actually using one function as the input into another function. So one function is actually composed or made up of the other function. The notation for this, if the two functions you're using are f and g, we have the function f of x and we have the function g of x. Well then f composed with g looks like f, then the little circle, then the g. This means that you take the function g and you put it inside the function f. It is the function f composed of g of x. Now you can write the order just the opposite and write it g composed with f of x. And that means you take the function f and put it inside the function g. So let's look at a couple of examples. Here we have the function f of x equals the square root of x plus 5, and g of x equals x squared. Here we want to find f composed with g. So that means we want the function f, and inside the function f, we're going to put the function g of x. Well, in this problem, the g of x is the x squared. So the x squared is what we use for the input into x, into the function f. Now the function f is the square root of x plus 5. But instead of using x, we're using an x squared. So this would be the square root of x squared plus 5. I simply replace this x with this x squared. Now, f composed with g of 3 means I can take this 3 and just plug it right into that composition, that newly formed composition. So this would be the square root of 3 squared plus 5. So that would be the square root of 9 plus 5, which is the square root of 14. I also could do, let's see, what's a good enough one here? The same functions, g composed with f. So this time I'm going to be putting the function f inside the function g. So everywhere I see an x in the function g, I'm going to replace it with the square root of x plus 5. So this is where my x is, so I'm going to have the square root of x plus 5 squared. Now I can simplify that, because if I square a square root, that simply means I have whatever is under the radical. So I end up with x plus 5. Okay, now g composed with f of 3 means that I'm going to take a 3 and put it into my g composed with f function. So that would be 3 plus 5, which would be 8. Now, let's take a look at this. If this means g of f of 3, I can also do this with my function separately. F of 3 would be the square root of 3 plus 5, which would be the square root of 8. So g of f of 3 is the same as having, g of the square root of 8. So then if I put the square root of 8 into my function g, I have the square root of 8 squared, which again gives you the 8. So that just gives you a different way to look at finding the value of your composition. Now here I have a table of values, so we've got to be sure we understand what's in this table. The first row are x values. The second row are the values of f of x. So if x is 2, f of x is 1. If x is 4, f of x is 6, and so on. Then down below that, I have another row of x values and the values of g of x. So let's take a look at this. Here I have g composed with f of 6. So that means I want g of f of 6. So first thing I need to do is go to my f part of my table and see what f of 6 is. So if I go to x value of 6, f of x, which would be f of 6, would be 7. So now that 7 becomes the input for g. So if x is 7, my value of g of 7 is 4. So putting the 6 into the f gave me a 7, and then putting the 7 into g gave me a 4. So my final function value there is 4. When we look at decomposition, we're basically just working backwards here. Here we start with a function that can be composed of two functions put together. So we want to find what function f and g you can compose to give this. You kind of want to look at where you might see groupings or parentheses taking place. I could put all of this, x minus 7, in the denominator within a set of parentheses. If I do that, I could call that my g of x is x minus 7. And then f of x would just be the function 3 over whatever's in those parentheses, which would be the x. So if I do f composed with g, I get 3 over x minus 7. So these could be my two functions. If we look at this one, because all of this is under the radical, I can kind of think of this as being in parentheses. So that part that's kind of the inside part, I could call my g of x. So that would be 3x minus 8. And then the f of x would just be the part on the outside of the parentheses, which is just the square root. So that would be f of x equals the square root of x. So if I do f composed with g, I have the 3x minus 8 under the square root.